Every second, 10 trillion neutrinos pass through your body, not one, not hundreds, trillions. They come from the sun, from distant supernovae, from cosmic collisions beyond our imagination, yet you will never feel them. You will never see them, because neutrinos, the ghost particles, pass through everything. The story of their discovery began with a mystery that in the 1930s, scientists studying radioactive decay noticed something was missing. When atoms broke apart, the energy didn't add up. It was as if the universe was cheating its own laws. Then, a quiet genius, Wolfgang Pauli, proposed the impossible. Perhaps an invisible particle carried away the missing energy. He called it a desperate remedy. But he was right. It took 25 years to prove that neutrinos exist. In 1956, physicists Clyde Cowan and Frederick Reynes detected them near a nuclear reactor, tiny bursts of light flashing in water tanks buried underground. That faint glow was history being written. For the first time, humanity had caught a ghost. Since then, the world has built enormous eyes to watch the invisible. The Super Kamiokande detector in Japan, a cathedral of pure water surrounded by 10,000 golden sensors, the ice cube. Observatory in Antarctica, a cubic kilometer of frozen silence, lit by blue sensors deep beneath the ice. Here, scientists wait for the rarest event in the universe, the moment a neutrino interacts. It's like catching a single snowflake in a hurricane, and knowing it came from the edge of creation. Neutrinos are born in fire, inside stars. Nuclear fusion forges them. When a star dies in a supernova, it unleashes a flood of neutrinos that escape before light itself. In fact, when supernova 1987A exploded, detectors on Earth caught its neutrinos hours before telescopes saw its light. These particles told us the star had died before the universe did, and yet, their nature defies understanding. Neutrinos have almost no mass, 1,000 times lighter than an electron, yet not zero. They can change flavors as they travel. Electron, muon, tau. It's as if they were made of uncertainty itself. They don't obey the rules we thought defined matter. They dance between being and not being. Quantum ghosts whispering secrets from the birth of time. For scientists, neutrinos are more than curiosities. They're messengers, because they pass through everything. They carry pristine information from places light can't reach, the hearts of stars, the cores of galaxies, even the moment after the Big Bang. To study neutrinos is to eavesdrop on the universe's most private conversations, but there's something deeper, almost poetic. Every neutrino that touches you has traveled billions of light years without stopping. It's older than your planet, older than your sun, and still, it continues its endless journey. Through you, through mountains, through the earth itself, unbothered, unchanged. We often think of ghosts as remnants of what once lived, but these are ghosts of what has always been, eternal travelers carrying the story of everything that ever was. And somewhere out there, right now, a neutrino born from a collapsing star is passing through your heart, silently reminding you that we are all made of motion, of energy, of wonder. The more we study neutrinos, the stranger they become. In 2015, physicists won the Nobel Prize for proving that neutrinos have mass, an idea that changed everything we thought we knew about physics, because if neutrinos have mass, then the universe is not balanced the way we imagined. There may be a new physics, something deeper, hidden behind the veil of these ghosts. Some scientists now believe neutrinos could hold the key to one of the oldest questions in existence: why is there something rather than nothing? After the Big Bang, matter and antimatter should have annihilated each other completely, leaving only light, and yet, we exist. Somewhere, something tipped the balance. Neutrinos may be that something. They might explain why matter won over antimatter, why you, and I, and every planet, star, and galaxy still exist. In that sense, we owe our existence to these silent ghosts. At the Ice Cube Observatory, researchers have traced the paths of neutrinos back to distant galaxies, pinpointing sources billions of light years away. Each one carries a fingerprint of the cosmic event that birthed it, a clue to what the universe was doing in its most violent moments. Neutrinos have become cosmic reporters, witnesses of creation, but the most haunting thought is this: they never stop. Long after Earth is gone, after the last star fades, neutrinos will still be moving. Silent travelers through an empty universe, they are eternal motion in a universe that will one day fall. Silent, perhaps that's why scientists call them ghosts. Because even when everything else ends, they keep going. So the next time you stand beneath the night sky, remember, it's not empty. It's alive with motion, with invisible streams of lightless matter, with ancient whispers passing through you from across eternity. You are not just looking at the universe, you are part of it, connected by particles that never stop, never rest, never die. If you found wonder in the invisible tonight, join us again, because the ghosts of the cosmos still have stories left to tell, here, on Beyond Universe Show.